far we've been working with things that were already provided by Unity. So we use cube shapes, we've used capsules, we've changed the material, but to make the player to be able to see things, we need to write some code, okay? Because, for example, if I hit the play button, I'm a bit far from the table, but I can't tell where I'm looking. I can't say if I'm looking at the table or at a mole, for example, and this is going to be needed. So first of all, we're going to the camera, and we're going to rename it to player. Okay, it's still a camera, it works the same way, but we need to understand that this is going to be the actual player. This is where the player stands. Okay, let's change the position on Z to -2 and on Y to 1.8. Okay, maybe a bit bigger, so 2. Okay, and we do this because we want the player to be closer to the table, of course. Okay, so we can see the moles like this, and we are able to look at them. And now that we have this, we need to write a script for the player. So we go to the project window, we right click, select create, and then we're going to choose C# script. And we're going to rename this as simply player. And as we save the script, notice that there's a little spinning wheel in the bottom right. This means that the code is compiling and Unity is getting ready for the scripts to work. Okay, and now before we write any scripts, let's make sure that the script is going to be attached to the player. So we select the player in the hierarchy, and we're going to select the script. We're going to drag and drop it in the player. And after this, you notice in the inspector that we have a player component in here, which is great. We are able to move forward. Now we double click the player script, and MonoDevelop is going to open, which is a nice coding tool. It already comes with Unity, it's free, it's open source, and it's just working great nowadays. Okay, so now we have the player script. And notice that there are already some lines written for us. So let's take a look on each of them. First of all, we have two using instructions here. They're basically importing some namespaces. So we can use some special names when we're writing this code and use some special logic that was already written for us. Now this is the definition of the class. Okay, so we're basically defining how the player is going to behave. And this class definition is going to have, or may have, properties, variables, methods. If you have never worked with them, don't worry, it's going to be pretty simple in here, but understand that inside the class we have the definitions of a few things. And we have already two here. These are two methods. Okay, and methods are like operations that are going to be executed. Okay, some instructions are going to be called once these methods are called. And the two that we have we have the first one, which is start. Okay, so whatever you write in here is going to be executed when this method is called. Okay, and it's called when the game starts. Okay, when this component is loaded. Okay, so when the player is ready to be used, then its start method is going to be called. And here we have the update method. So whatever you write here is going to be executed once per frame. So your game is running all the time. It's running, it's executing its logic all the time. For example, in general, if a fast game is going to be executed 60 times a second, and the update method in this case would be called 60 times a second. Okay, so this is great for us to write our looking logic. To write the looking logic, we need to understand one thing. We're going to perform a raycast, and a raycast is like we are shooting a laser in a certain direction. Okay, so in our case, we have the player. Okay, the player contains a camera component, and we want to, at all times, whatever the player is looking, we need to see what they are looking at. Okay, so we need to kind of shoot a ray. It's like we are in a shooter game. We're going to shoot a ray, and we're going to, for example, print the name of whatever the player is seeing right now, and later we work on the mole hitting logic. So we're going to our code, and in the update method, we're going to type this. Raycast hit. What we're doing here, we're declaring a variable that is going to be used in this scope. And a variable is a position in memory that is going to store something. Okay, and instead of memorizing a huge number, we can just use a human readable name, which is hit. Okay, and here when we type raycast hit, we're saying that the thing that's going to be stored in this variable is going to be of type raycast hit, which basically stores information of whatever we hit if we hit something. Okay, and a semicolon here is to finish the statement that we just wrote. Okay, and to perform the actual raycast, we need to use an if block. So we type if open and close parentheses, and open and close curly braces. This is a conditional block. We're basically going to ask a question here, and if this question is true, this is going to be executed. If this question is false, then whatever you write between these curly braces is going to be skipped. So for example, if we ask if apples are the same thing as oranges, okay, this is false, this is a lie, so whatever is here is not going to be executed. But if we ask if 2 plus 2 equals to 4, then this is evaluated as true. As this is evaluated as true, then this is going to be executed. Okay, so we're going to perform a raycast, and we want to know if we hit something. So we're going to type this, physics.raycast, and we open and close parentheses. So when we type physics in here, we're going to access a global physics class of Unity. Okay, so as you can see in the summary, it's global physics properties and helper methods. Okay, so we are in the right spot. When we add this dot operator here, it means we're going to call or access something that is inside this class here. And raycast is a method. Okay, we have the start and update methods in our player class, but we also have a raycast method in the physics class. And this method contains several signatures. Okay, we can pass different parameters in this method, and it's going to perform the raycast. And we're going to use one of the most basic signatures for raycast. So we're going to pass parameters in this method. Start and update, they don't receive any parameters, but raycast receive. It's like we are watching a TV, for example, and you want to change the channel. The method change channel requires a parameter, which is the channel you want to go, for 35, for example. So the first parameter that I'm going to use here is the origin of the raycast. And this is going to be easy because the origin of the raycast is exactly where the player is standing. And to get the position of the player, we simply type transform.position. That's where the player is standing. The second parameter is the direction of the raycast. And this could be done with some very complicated mathematics, but in Unity we can just type transform.forward. So this is going to be an arrow that's going to point forwards and to whatever the player is looking. And notice something important here. Position is a vector 3, and forward is also vector 3, but they work differently because this vector 3, okay, as vector 3 in general, they are a collection of 3 values, x, y, and z. It's the position in the world space, okay, so that's a point. But forward, on the other hand, is going to be a direction. Okay, so instead of being a point, it's going to be an abstract representation of an arrow that is going to point somewhere. It could be left, right, top, bottom, forward, backward, to whatever direction. Okay, it's just for you to understand that there's a difference. And the third parameter that we're going to add here is if we hit something, then it's going to be stored in a certain place, which is our hit variable. So we type out hit. Okay, because this method is going to write in this variable here. Okay, and the reason we put all of this in this if block is because this raycast call is going to return true if we hit something, or false if we hit anything. And if we didn't hit anything, we don't even want to access the hit variable because it's essentially null. It contains nothing. Okay, so since we are here, it means we hit something, and let's say we want to print the name of whatever we are seeing here. So we're going to type debug.log because we want to print a message in our console. And between parentheses, we're going to type hit.transform.name. So we print the name of the game object that we hit. So we save this, we go back to Unity and wait for a compilation to complete. And we're going to choose the console window just to see if we have any code mistakes. And if we didn't and we hit play, we're just going to print whatever you're looking. So if we look at this mole here, it's going to print mole 3. If we look at this one, mole 2. This one, mole 8. If we look at the table, it's going to print cube 9, cube 6, so all of the components that we added in the table. Okay, so we can successfully understand where we are looking. Okay, and however, we just want to, for the looking logic to execute, if we press the Google Cardboard button, okay, because it's kind of going to simulate like we're hitting the moles with a hammer. So to do this, we're going to enclose all of what we've written in the update method in another if block. So we type if, open and close parentheses, open curly braces, let's ident this, and then close the curly braces. And the question that we want to add here is, we need to understand if the Google Cardboard button has been triggered. So we type gvrviewer.instance.triggered. That's all we need. But since we are working in the Unity editor in the computer, to make an easy test, let's say we want to use the space button as well. So we can add an OR instruction here, okay, and we're going to type input.get key down, and between parentheses the string space. Okay, so that means that whatever we write in this if block here is going to be executed if this is true or if this is true. Okay, so it's going to work on both ways. So let's save this. We go to Unity, wait for the compilation to complete, and we're going to hit the play button, and we're going to press space while we are looking at a mole. Okay, so we look at one, we press space, and it prints mole 6. Okay, but not printing all the time. So this is great now. However, we of course don't want to print debug information. This is of no use to the player. So we want to know if we hit a mole. To do this, we're going to make a mole class, and then with that in mind, we can understand if we are hitting one. So in the project window, we right click, select create, then C# script. This is going to be named mole. Okay, let's wait for the compilation to complete. And while it is working here, we can choose the first mole that we added, and we're going to drag a script to it. Okay, we can drag to the mole like this, or drag to the inspector, making sure that the mole is selected. Okay, so we have the mole script. We're going to hit apply to make sure that all the other ones are going to have this script as well, as you can see. And back to the player. Instead of typing this, we want to see if the game object that we hit, okay, the entity that we just hit, contains a mole component, because if it does, it means we've hit the mole. So here we're going to type if hit.transform.getComponent, and now we need to pass the type of the component. We're going to simply pass and see that we're going to use a lesser than and a greater than sign, and between these two characters we type mole, which is the class we just created. We open and close parentheses as this is a method call, and this is going to return the mole, the actual reference to the mole class if we hit a mole, but if we didn't, it's going to return null, because it means the game object that we hit contains no components of type mole. So we want to check if this is different than null. Okay, so we add an exclamation sign and an equal sign to see if it's null. We open and close curly braces, and now we can, for now, just print debug.log hit a mole to print this message. So we can save this, go back to Unity. We're going to wait for the compilation to complete, and after it is complete, we're going to hit the play button, and there we go. And if we press space, we see that we print the message hit a mole. Okay, so we have 1, 2, 3, 4. Notice that this number is counting, or if you have this collapse option disabled, it's just going to print message after message. Okay, so that's great. We have all the looking logic. We can already communicate with the moles that we have in here. And now that we did this, let's make these moles to move down once they are hit. To make the moles to be hit, we need to change how its script works, okay? Because right now it's just an empty file. So if we look at the mole in the mole container, we notice that its vertical position right now is 0.2. So if we hit it, we want it to move to another one, like minus 0.3, for example. So it's under the table. So to keep this simple, let's use 0.2 as the position when the mole is risen, and minus 0.3 when it's supposed to be hidden. Okay, so we're going to the mole here, and we're going to add two things. Okay, we're going to declare what we call a variable. Okay, so we've worked with variables before in the player, declaring this hit one, but in the mole it's going to be a bit different. We're going to declare it in the class. So we're going to type public float. Let's use this as visible height. You're going to set this as 0.2f, and we're going to type public float hidden height, and it's going to be 0.3f minus 0.3f. Okay, so what are we doing here? We're declaring two variables. The first one is called visible height. We say that whatever is going to be stored here is going to be a floating point number. That variable is going to be visible to other classes and to the Unity editor. You're going to see that shortly. And I'm already assigning it to a value. It's 0.2f. Okay, it's a floating point number, right? And a semicolon to finish this statement. We do the same thing for the hidden height. We use minus 0.3f. If we save this script and we go to Unity, we wait for this to compile, and if you look at the mold component, there are two fields here, visible height, which is 0.2, and hidden height, which is minus 0.3. And all of the other ones, they contain this default value. So if you want to change this to something like 0.25, you need to apply this, and the other ones are going to be updated, as we do with prefabs in general. Okay, let's just use 0.2 and minus 0.3. Okay, so now that we have this, let's say we want to make the mold to move down. Okay, so we're going to be needing something here. We're going to type private, then vector3 target position. Okay, so the target position is going to be something that the mold is always going to keep in mind. Okay, so it moves to that position. And when we start the game, we want to set target position to be a new vector3. Okay, you're going to understand what we're going to do this, why we're going to do this. So we want the target position to be where the mole is standing right now. Okay, so this mole is on 0, 0, 2, 0. This one is on minus 0, 9, 0, 2, 0. So wherever the moles are located, we want to set the target position to be the state where the moles are hidden. So we're going to use X and Z, whatever their values are, and we're going to force Y to be the hidden height. Okay, so this is what we're going to do. We're going to make a new vector3, and we need to pass X, Y, and Z as the parameters for this constructor. Okay, because we're constructing a vector3. Okay, so on X, we're going to use whatever value is here. So we're going to use transform dot local position, because the position is relative to the mold container, dot X. As for Y, we're going to use hidden height, and as for Z, we use transform dot local position dot Z. Okay, so this value is going to track where the molds need to be, okay, in this target position. And now that we have this information, we want to make the mold to slowly move to that position, whatever it is. So to do this, we need the update method. We're going to type transform.localPosition is going to be vector3.lerp. Okay, so this is going to be an interpolation, so we make a smooth movement between one vector3 and another one. So this is going to require three parameters. The original position for the moles is where they're standing right now, so we use transform.localPosition. Now the target position for the interpolation is going to be the target position, the variable that we just created, hence this name. Okay, so we type target position. And the third parameter is a time component, so we can just type here time.delta time. Okay, you don't need to understand the details of this, but basically if you use higher numbers here, it's going to move faster. Okay, so we're going to save this. We go back to Unity, wait for the compilation to complete, and let's see if the molds are going to hide themselves. Okay, we wait for the spinning wheel to finish, no error so far. We hit the play button, and all of the molds, they are hidden now. Okay, they just moved downwards. However, they're moving pretty slowly. I think you feel the same. So to make them move faster, we can just make a variable. So public float speed, and let's set that to 4f, for example, in the mole. And in the update method, when we type time.delta_time, we can multiply that by speed. Okay, so we save this, we go to Unity, we wait for the compilation to complete, and after it is done, right now, okay, so notice that all of the molds that contain the speed 4, if we hit the play button, they should hide much faster. Okay, we can even see them appearing. Okay, so this is great. We already made the molds to be to go there. Okay, so however, just for testing, in the beginning, instead of hidden height, I'm going to type visible height. Okay, so they should be standing here, visible. All of them are going to be visible. And the logic that we want to do is, if the player looks at a mole and hits space, then the mole is going to hide. Okay, so this is what we're going to do. In the mole, we're going to type, we're going to make a new method. We're going to type public void on hit. We open and close parentheses, and we open and close curly braces. So if the mole is hit, we want to make it move down. So to make it move down, we can just copy this target position here. We can copy it from here and paste it here in the on hit. And instead of visible height, we use hidden height on Y. Okay, so this is going to change the target position of the mole, and the update method is going to ensure that the mole is going to go to this position here. And in the player, if we hit a mole, like we're doing right now, we need to call that method. So let's store a reference to this mole. So we type mole equals to this. Okay, so we can just copy it and paste here and add a semicolon. So we're going to type now mole.onHit. So we open and close parentheses, we save this, we go to Unity, we wait for the compilation to complete, and after it is, we're going to hit the play button, and we should be able to hit all of the moles that are visible here. Okay, so if you press space, they all move down. Okay, so we hit all of them, which is great. Okay, which means we can already hit these moles properly. Okay, so let's go back to the game, and in the mole, we set its target position to be hidden height. Okay, and to ensure that they're not going to be animating in the beginning of the game, we can force the position to go straight to the target position. So you can type transform.localPosition equals to target position, and we can save this script. Okay, so now that we have this, we need to work on a logic to make the moles appear from time to time, so they're going to rise. Okay, let's work on this in the next video.